Today I'm going to talk to you about electron configuration and orbital notation. Just to review, electron configuration is a chemist's shorthand way of showing how many electrons an atom has in each one of its sublevels. So it's just a way to show where you find electrons in an atom. Now, we're going to talk about the fact that each sublevel contains a certain number of orbitals and electrons. Now remember, there's four main sublevels. You've got the S, P, D, and F. In S, there is only one orbital, and if you recall, every orbital holds 2 electrons. So since there's one orbital in S, there's 2 total electrons in the S sublevel. In the P sublevel, there are 3 orbitals, and 3 times 2 makes 6 total electrons that can be on the P sublevel. D has 5 orbitals, and each one of those holds 2, so that's a total of 10 electrons. F has 7 orbitals, and therefore has 14 electrons. Again, 7 times 14. Here's just a quick little view of each of the different orbitals. So here's the S level of orbitals. Here's the P sublevel. And you see the 3 different possible ones. We have the 5 for the D down here. These are the Ds, and these are the S orbitals. Now, in order to help us understand how electron configuration works and how orbital notation works, we're going to use an analogy that I call my apartment analogy. Think of this as the atom as an apartment for electrons. And to understand that, we're going to use a couple of terms. First of all, for our shells, that's analogous to the floors on an apartment building. So you have different floors in an apartment building, and the shells are just like the different floors in the building. For the sublevels, it's like the different apartment types or floor plans. So for example, you might have different room number floor plans. So like you might have a 1-bedroom apartment or a 2-bedroom apartment. Or you might even have different versions of like 2-bedroom apartments. So you might have one that comes with a big bay window, while another one that comes with a balcony. So those are different floor plans that you can have. And so those are like the sublevels. The sublevels are like different floor plans. And then the orbitals are like the different rooms. So within each floor plan, you have a different number of rooms. And then the electrons, they're like the tenants. Those are the people you're moving in. And the idea is we want to find a place for all our electrons to fit into a room of an apartment. So going back to here, we can use this as an example. So I like to think of the S as the suite apartments, a suite floor plan, P is the penthouse floor plan, D is the deluxe floor plan, and F is the fantastic floor plan. If that helps you remember the different types, then use that. And when we're moving these electrons into these apartments, we have to follow certain rules. There are specific rules for how we move them in. And these are the 3 rules that we're going to be following. First is called off-boss principle. And off-boss principle states that electrons will occupy orbits of lower energy level first. I call this the electrons are lazy rule. The idea is they don't want to go upstairs if they don't have to. So they're going to go on the lowest floor available to them. So you fill up electrons, or you fill up the orbitals on the bottom levels before you go up to the next level. So you fill up this first sublevel first and second and so forth. The second rule we're going to look at is the fact that each orbital can hold up to 2 electrons. This is called the Pauli exclusion principle. And this is just the idea that 2 people per room. You don't want more than 2 people in one room at a time. The orbitals are the rooms, electrons are the people, so we have 2 people per room. And the reason why it's 2 is electrons can either spin clockwise or counterclockwise, so they have just one or two possible spins, and that's why there's only two possible electrons in every orbital. And the third rule kind of builds on that. It's called Hunch Rule. It says that each orbital within a sublevel must receive one electron before any of them can receive two electrons. That sounds really complicated, but to understand this, I just think of this as the don't share rule. And the idea is electrons don't want to share a room if they don't have to. So unless you have to fill up the room, then you're only going to put one electron in each one. Now this one is the third one on purpose. This is the order of the rules as they go. So you have to fill up lower energy levels before you worry about not doubling up and so forth. So we're going to, now one thing to take note of is going back to Aufbau's principle, this idea of lower energy levels first. Those are so we have the first shell, the second shell, third shell, fourth shell, etc. Those are the floors. But one to take note of is as there's different number of orbitals and different number of possible sublevels within each floor, they are all at different energy levels. So think of this in our analogy. On the first floor, there's only one apartment, an S apartment, an S sublevel. In the second floor, though, there's two apartments. There's an S apartment and a P apartment. But in order to get from the S apartment to the P apartment, you have to go up not a complete flight of stairs, but some flights. And so this takes energy. The third floor, the third shell, has three sublevels, three building types, a S apartment, a P apartment, and a D apartment. And these are all also at different levels. Well, the fourth one, if you look, the fourth floor starts actually lower than the third apartment, the D apartment, on the third floor. So it's actually easier for them to get into the 4S apartment than it is to get into the 3D. So we follow this pattern that's outlined by what's called the Aufbau diagram, where we fill up the 1S first, then the 2S, and then we come back around here and then start filling up the 3S, 3P, 4P, but before we, or 3P, but before we do the 3D, we do 4S. Then we come around, and this diagram shows the order of how we fill up all of the apartments. It is still following that first rule, but you'll notice that before we fill up the first one, F apartment, the 4F, we actually fill up 6S, 5P, and 5D before that. And then all the Ds are actually one behind. We fill up the 5S before we fill up the 4D, and fill up the 6S before we fill up the 5D, and so forth. And we will end this video at this point.